Alright, so this is review question number 2. Richard, of mass 65 kilograms, pushes Max, of mass 75 kilograms, on a surface with force 285 newtons east for 0.1 seconds. The coefficient of kinetic friction is 0.05. Assume they start from rest. A. Calculate Richard's acceleration. Alright, so this is a classic problem where we have two people on rollerblades or on some kind of surface which is maybe a little bit slippery, push off against each other. And so first we're going to draw the situation with free body diagrams. So we have Richard and we have Max represented by these boxes, and we know that Richard pushes Max to the east, right? So this is going to be Richard on this side, and this is Max on this side. And Richard pushes Max with a force of 285 newtons, right? So Max has this applied force, which has a magnitude of 285 newtons. Now, this has an equal and opposite force, right? Due to Newton's third law, which is 285 newtons in the exact opposite direction. Apart from these forces, we know that we also have a force of gravity, a normal force, and a force of kinetic friction since it's moving. And for Richard, we also have a force of gravity, a normal force, and a force of kinetic friction. Although remember, since they don't have the same mass, these forces of gravities are not equal, these normal forces are not equal, and these forces of kinetic friction are also not equal to each other. Really, it's just these two forces that are equal to each other. And then we also know that since it's not accelerating upwards or downwards, that these forces are equal to each other and these forces are equal to each other. Okay, so now we have the situation drawn. We want to calculate Richard's acceleration. And so we're looking at Richard. We know that his mass is 65 kilograms. And so we know that in order to find his acceleration, we're going to have to end up using Newton's second law, right? The acceleration of Richard is going to be equal to the net force acting on Richard divided by his mass. So let's write that equation out, right? Our last step, our last calculation is going to be the net force acting on Richard divided by his mass. All right, and right off the bat, we know his mass is 65 kilograms. And so now the next step of this problem is going to be to figure out what the net force is. So the net force acting on Richard is going to be equal to the normal force plus the force of gravity plus the force of kinetic friction plus our applied force, right? Okay, and so we know that the normal force and the gravitational force are in equal and opposite directions acting on the same object, so these are going to cancel each other out, and so we're left with the force of kinetic friction plus the applied force. Now, of course, the applied force we know is just given to us. It's 285 newtons to the west. Now what we need to do is find this force of kinetic friction. And the force of kinetic friction, as usual, is going to be equal to mu k times the normal force. And we know that the normal force is equal to mg in this case. So this is going to be equal to mu k mg. And so now we just really have to put our numbers in. So mu k is 0.10, is 0.05. Our mass is 65 kilograms, and g is 9.81. You put that into your calculator, and you get 31.88 3.825. And for now, I'm going to keep my numbers. I will round them at the very end. Okay, so now when we put our numbers in, we have to be careful about the direction, right? So let's say right is positive. So what that means is that our force of kinetic friction is going to be positive. So that's going to be 31.8825. And our acceleration, sorry, our applied force is going to be the negative direction. So we're going to subtract 285 newtons, which is negative 253.1175 newtons east, which is the same thing as positive 253.1175 newtons west, right? And so that makes sense. The net force is in the west direction, so we do expect our acceleration to end up being in the west direction. Okay, so now we got this number, we can put this into this equation. So this is going to be equal to minus 253.1175 divided by 65. Put that into our calculator, and we get minus 3.894 meters per second squared east. So now rounding with significant figures, this is the same thing as 3.9 meters per second squared west.